Yeah, Hynek already said before, my name is Simon. I'm technical account manager in the OEM area. I'm mainly focused on the Volkswagen Group in Germany, also here in the Czech Republic. And yeah, today I wanted to talk a little about our concept platform, what we have in our toolchain, and how in the automotive market, especially the new EVs are using this platform to accelerate their development. The traditional automotive industry is struggling a lot at the moment. But I think that's everybody clear, so we can see, we can read day by day in the newspaper. So this new EVs interrupts the competitive landscape of the automotive markets, especially of the traditional automakers. They are 30 to 50% faster in terms of development speed as the traditional one. Yes, for sure, they are starting on a green field. They don't have to care about well-established processes. They don't have to care about deleting silos like in the past. But this is not the only reason why they are so fast. To be honest, we are working also together with these new kids on the block, in quite close partnerships. They are using our tools, and one main reason what I see in my work with the European OEMs in the last years, and also what I hear from my colleagues when they work with these new EVs, they are much faster and much more open to new innovative approaches. They are not only much more open, they are also much faster in adopting this technology. Adopting it means in this case, bringing it to a stage that they are really using it in a productive manner. Not only a benchmark, proof of concept, and then the discussion starts how they can use it in production. They are simply doing it and testing it live. And that's why we are here, right? Or why you are here, to get some more insights, to get some more ideas how these tools, what you also have the license for, what you already can use today, how you maybe can use it in the future much more efficient. Altair's DNA is simulation, for sure. So with this message, we are now running around and shouting it out since 40 years. If you believe it or not, these new kids on the block, they are following us. Simulation is one of their basic pieces they heavily rely on, especially in the early concept phase. They don't need a designer who tells the supplier or the experts what they should do, what they need, what they should design. They're using an easy, accessible concept platform and doing it by their own. And the main point is here, they are doing it on their native CAD model. So they have only one single source of the CAD model, and everyone is working on that. If you have a challenge question you have to answer, and you have to explain your CAE expert, let's take an example, CFD question. If you have to discuss with the CAE expert what he should do, and he tells you what he needs to answer these questions, then you have to wait, how long? 2-3 weeks until you get the answer? Quite common in a big OEM that you have to wait so long. But your meeting is maybe in half an hour, and it would be great to have an answer. Maybe an idea, does it make sense what I want to suggest, to discuss it with neighbor departments. If you have to wait 2 weeks, this will not bring you closer in terms of development speed to the new EVs. Definitely not. The next point is, what is a very big point in development costs? We develop a part, purchasing department choose one supplier, the tools are already ordered, they started to produce it. At this point, you gave your design to the supplier, and what happens? Normally, they say, thank you, perfect, but they come back to you and say, yeah, great, we can manufacture it, but we have to do some slightly changes here, slightly changes there to produce it. This happens at maybe 80% of the parts. So the iteration starts part by part. The overall system also needs to be checked again to have the green flags everywhere. And this is very time consuming, and also in terms of time and money. So manufacturability is here also a key. Designing, manufacturability, these are dependencies. So it's quite important also in the early design stage that you can cover these dependencies. What happens in my subsystem or in the overall system if I change locally a part? And these dependencies can be very good controlled with such a concept platform. Or let's say the other way around, it's more a software seller pitch. This is how they are using this technology. Dependencies. Understand dependencies to create first-time right approaches. Yeah, and this is exactly the reason why the traditional manufacturer, how to say in English, have some troubles to adopt such an approach. They have grown processes, established processes, and to throw everything away, it's impossible. But on the other hand, there is no excuse. We see day by day, if we are not changing the processes or the way how we develop cars, we will be not losing the race, we will be lapped in the near future, definitely. Because the new EVs, they are not stopping at the pit lane, they are on fire. We have to speed up, at least speed up. With such a platform, we have the experience that all these challenges can be addressed quite easily if you set up the surroundings correspondingly. What does that mean? With an increase of speed, in the concept phase at a single source, you can create more variants and you can create more creativity in the same manner. This directly reduces the number of development loops and pushes the first time right approach. So with the first design you have, you can deliver higher quality models. So what does that mean in detail if we are looking into applications? Let's zoom in a little bit in our model, and I first want to have a look at my suspension system. In this subsystem here, we have a question regarding brake cooling. In an early concept phase, we don't need a super high fidelity CFD model with several boundary layers, with values they are accurate from 3 digits behind the comma. We need an idea. Does the idea what I have, does it work? And am I in an acceptable range that when I fine-tune this model, can I fulfill the requirements? If not, what parameters do I have? And then I need to discuss these parameters with my colleagues. Am I allowed to change these parameters? Yes or no? No? Okay, then we have to go one step back, have to think about another concept. But it has to be quick. 3 weeks, too late. This use case here is based on I created together with a German OEM in this case. So this user uses the Inspire platform, yes, but never touched CFD. And he needed round about 3 hours to set up this case here. So a brake disc with inside cooling to get an idea how much air flow is inside the brake disc. To take a decision if this concept, is it worth to have a detailed investigation or not. Suspension system. Another point for sure, what influences my airflow are the part itself. What kind of part? For example, here, this arm, and another dependency, what we have? Weight. For sure, if we can save weight, in automotive industry, as in a lot of other industries, quite common and useful. But coming back to manufacturing, if you are designing casting parts, one crucial thing is manufacturability. Manufacturability, classical approach, we run some topology optimization based with with casting constraints, yes, okay. But at the end, you have to run several loops. You run a casting simulation to check your design. Okay, fine-tune the optimization setup, run again, and so on. So it needs some iterations, manual iterations. Ideally, what would be much more beneficial, we include a casting simulation into our topology optimization. That means we run topology optimization until we get a certain discrete result, and then automatically a casting simulation is started. We know which are critical areas for casting. These areas are constrained, And in the next X iterations, these areas are minimized or deleted by the topology optimizer. And so we can save all these iterations and directly get this result. So topology optimization with integrated casting simulation. This will be available in the next version of Inspire. So we have this technology, and it's already available for the expert users in OptiStruct. Another dependency. I already mentioned weight. What is the most important impact of weight in the automotive development? Yes, battery. Quite clear. Battery capacity, battery, also the driving range. If we can save weight, we have a higher driving range, or if we want to keep the driving range, we can maybe use other battery concepts, cheaper battery concepts, to make our car more competitive against our competitors. We have 3 suppliers with 3 different high voltage storage systems. So, in each battery frame, I think it is 8 high voltage systems goes inside. That leads, in this case here, to a model of 4,500 parts, 1,200 parts, and here nearly 14,000 parts. If you think about your company, how quick would you think you would be able to take a decision which is the most promising concept, which it makes sense to investigate more? It doesn't matter what number is now in your head, you can be sure the new EVs can do it in a fraction of time. What does that mean? Let's start. Yeah. So, the question, what is the most promising concept? What we have here, I already go through it. Oh, the number deviate, I just see here it's 6,000 parts, but I think this one is correct. The other one was another version. For sure, we have to simplify in the early design phase. We are not interested in the 3 digits behind the comma. We need an idea, does it work or not? With meshless technology, it's possible to do all the 3 concepts within 1 day. No geometry simplification, no meshing, everything in 1 day. A design direction. Does it work, yes or no? And how much things I have to change? So we are talking about between 10 minutes and 13 hours. The most important thing is you don't need the best HPC machine from Google to do this. I did this here on this laptop. But how could that be so quick? 13,000 parts on this machine in 24 hours. What's behind? In this case, it's meshless technology. It's from my point of view, groundbreaking technology. What is not new. We bought it several years ago, but we included it in the concept platform. What is it? It's a structural solver which is running on the native unsimplified cut geometry without creating a meshless. And it's trimmed on speed. Speed, speed, speed. Who is using it? As I said, the new kids on the block, yes. They are heavily rely on these technologies to speed up development, to speed up the time to market. And as you can see, it anyhow pays off. They are much, much quicker. The question is, what's about the traditional automaker? Do they close their eyes? Are we not telling them that this technology is available? For sure, we are telling it to them. And you also can see here, for example, Jaguar Land Rover. They are also using this technology in a productive manner in their production, in the departments. But the main point what I see from the first meeting when we introduce it, proof of concept, until it goes into production, well, there are reasons why they are so fast in the development speed. And why it will be very, very interesting and challenging for us in the traditional market to speed up with them. Nevertheless, you have this platform. We all here, we are the innovation driver. We should use these tools, this technology, what is available, to accept the competition and to fight back. I think every one of you is using our tools, so you have the licenses already in-house. You also have these tools in-house. And if not, I'm pretty sure Hynek will be quite open to give you the possibility to use this. Thanks a lot.